My name is Nikhil Chandrappa. I'm a software engineer in Yugabyte. I work in the ecosystem team where we build integrations for a lot of developer tools like Spring, GraphQL, and also we build drivers for Yugabyte DB like YSQL and the YCQL drivers. Along with me, I have today Amey Banarse.
Hey folks, just for a quick introduction, I'm Amey Banarse. I'm the Vice President, VP of Products here at Yugabyte. And both Nikhil and I will be doing an interactive session with you folks, basically going through the hands-on development of microservices like Spring microservices with Yugabyte Distributed SQL database. Uh, Nikhil, anything else you want to add before, as a prereq setup before we start the workshop today?
So basically, the workshop that we have today is a Spring Boot based workshop, right? It's like if you want to get started, you can use a Yugabyte DB cluster on our cloud. I mean, that's not a prerequisite. You just need to have like a workspace, Java installed, and maybe like an hour's of 1 hour time so that you can follow whatever we do in this hands-on workshop.
Sounds great. So what we'll do is for the next 10 to 15 minutes or so, we'll give you a quick overview of like why is Spring and Yugabyte a great combination for your enterprise microservices. And then we'll switch to the hands-on part where you'll actually be deploying two separate microservices today using both of the Yugabyte's APIs, that is YSQL and YCQL API. And then you'll be doing your part of deploying it on any platform that of your choice, that is Kubernetes or virtual machines or anything that you prefer that way. The technologies we'll be using will be Spring Boot and Spring Data modules, and we'll go over in depth on like how we'll be using it, on how we can configure it and things like that. Next slide, Nikhil. Right. And then before we all get started, as you folks would have heard today through most of the sessions in this Distributed SQL Asia Summit, Yugabyte is a transactional database, which is essentially a 100% open source database, Postgres compatible, and would help you solve some of the real-time front-facing use cases, wherein you would have zero bottlenecks when it comes to scalability, and it's resilient by default and provides you HA, and it's actually built to run across multiple cloud environments. That is, you can deploy Yugabyte in your single cloud environment across multiple AZs, multiple regions, or actually do a hybrid cloud deployment of sorts. Let's say a single Yugabyte clusters across Amazon, Google Cloud, and Azure. And some of these things you would have already seen in the other sessions during the conference today. What you see on the slide is essentially a few set of customers or household names that are using Yugabyte today for solving some of their core business challenges with Yugabyte, and really using Yugabyte for getting the HA and resiliency with familiar APIs, that is the SQL API, which is Postgres compatible, and the Cassandra API, which is 100% Cassandra plus adds a lot of transactional capabilities to your Cassandra storage layer as well. So as I mentioned before, what you see on the right-hand side is a quick preview of like how each node in Yugabyte would look like. That is, the lower half of the layer is what we call as a distributed storage system, or we call it DocDB. That is a distributed document store, which is essentially a custom RocksDB storage layer that provides us like distributed transaction capabilities and uses Raft as a consensus protocol to provide sharding as well as replication of the data inside Yugabyte. And then on top of that, we have two separate APIs. And this is where you get the most value out of Yugabyte. That is, your existing applications or microservices don't have to go through a transformation or rewriting of APIs, because you can leverage the most familiar APIs, that is PostgreSQL and Cassandra today with Yugabyte, with absolutely no code changes or maybe minimal code changes, as you'll see today, to gain more performance from Yugabyte in general. So the two APIs that we exposed today are YSQL, which is Yugabyte's SQL API, which is a fully wire compatible PostgreSQL API. The Postgres dialect we support is 11.2. And then the second one is Yugabyte's cloud query language API, which is compatible with Cassandra, but also provides you a lot more than what Cassandra would traditionally offer. That is distributed transactions and consistent secondary indexes. Also JSON-B data type. That is something that most customers really leverage from Yugabyte. Next slide. Cool. Now, over the next few slides, we'll take a look at why do enterprises need such a distributed SQL database when they are doing fantastically well when it comes to breaking down their monoliths and using microservices. So what you see on the left-hand side right now is how a traditional monolith app would have been built, let's say like a MVC layer kind of application using a traditional SQL database, let's say Postgres or MySQL single node for that example. Now, when these enterprises go through transformation, they break up this monolith into a bunch of microservices, which share the responsibility based on a specific domain that they would target. So typically, there are certain patterns that enterprises would follow, domain-driven design being the most popular one, wherein you break up these monoliths into set of microservices which interact with each other and still leverage a traditional SQL database, right? So if you look through the story and if you go to the next slide, you'll quickly see that the traditional SQL database kind of becomes a bottleneck as and when you're expanding the scope of microservices or scaling them out based on the user traffic and demand, you quickly start hitting the bottlenecks that are given by or like set by a traditional SQL database. That being like connection pool exhaustion, be number one. Second thing can be if there is so many queries that are concurrently running on the database, then you'll start seeing a lot of higher query response times and kind of deteriorates the end user experience with this as well. The third thing that we typically see as one of the core bottlenecks when it comes to such single node databases is the overloading of database connection pool itself by multiple requests coming in. And then you need to kind of start putting in a query limiting layer on your microservices front so that you do not take all the resources from a single database itself. Some of the others that, and again, like these problems have existed in the industry for a while, and there are solutions or workarounds that you can do to make sure that you can alleviate some of these things, but they traditionally don't come from the database itself. They come from like some creative thinking done by architecture teams, that is putting a load balancer in front of a database and having multiple replicas so that you can create something like read replicas or asynchronous replication of the data itself, and then shard that data on the application side plus database side so that set of microservices only point to one active database over time. Or if you're doing something like scaling the writes vertically, that is expand the database resources itself vertically so that you can grow the database footprint so that it can handle more connections or more data over time. But all of these solutions are kind of patchwork towards like what the real end state that you want it to be, that is a cloud native microservices blended with a cloud native database. And that's what we'll be focusing on today during this workshop. So essentially think of it as you have a Postgres database and a set of microservices with a UI app attached to it. And once you start scaling out these microservices, the what you get with Yugabyte would be a distributed transactional database which can scale up and scale down based on like just a few clicks or even a single click for that matter. And this is cloud native enough that you can go and deploy it on any form factor, that is Kubernetes, bare metals, or virtual machines. It really doesn't matter. It's a 100% open source database. And this gives you the best of both worlds. That is, now you can have enterprise microservices scale out at any point of time. And at the same time, you can scale out the database to meet their demand rather than having any downtime for your end applications or having any bottlenecks in performance with your end applications. Next slide. So after this point, Nikhil will walk you through what is Spring Framework in general, and then wherein we support, like Yugabyte comes into the play and Yugabyte starts supporting different models of Spring Framework.
Thanks, Amey. That was a good overview. Okay, so when it comes to the Spring Framework ecosystem, right? Like Spring Data is one of the most popular Spring projects out there. Maybe like Spring, if you say Spring Web is Spring Web might be considered as one of the most popular, but Spring Data is also up there, right? So the reason being, Spring Data provides like a framework for accessing a bunch of different databases without actually like a developer need to know what's like the underlying SQL language, right? So he needed he need not go ahead and understand all the intricacies of those languages. He's just given a common API for him to access. That's what Spring Data provides, right? Spring Data provides an abstraction on top of any database for accessing the data. I mean, Spring Data JPA has been very popular over the years, and now Spring Data actually provides support for pretty much all the other NoSQL databases out there. So in today's session, we're going to see how the Spring Data integration with Yugabyte is going to work, and what all Spring projects Yugabyte is compatible with, and how we can actually go ahead and implement our microservices using Spring Boot and Spring Data with Yugabyte DB. So as Amey mentioned, like we support two APIs, right? We have the SQL, the Yugabyte SQL API, and also Yugabyte SQL API. For SQL, it's a Postgres compatible API. So Yugabyte just for any Spring Boot apps to work with the SQL API, you can just use the Spring Data JPA for connecting to it, right? And also, what we have underneath is we have a YSQL Postgres JDBC driver, which is an extension of the existing Postgres JDBC driver. It's just that we have extended it to be cluster aware. We're going to expand what the cluster aware actually means when we are doing the actual coding. For now, consider this JDBC driver is extended to understand having multiple nodes in a cluster. And also we have the CQL driver or the CQL API, where we work with Spring Data Cassandra to support some of the like access pattern for using Yugabyte DB, right? So these are the two main Spring Data projects that Yugabyte DB is compatible with. And the reason, and we have actually like a very first class support for Yugabyte DB with Spring. So using our drivers with Spring Data, what you kind of get is you, as an app developer, you kind of have allow Spring Data to deal with all the boilerplate code, like creating the connection, pool, data source, all those stuff is taken care by Spring. And also you have the familiarity with using Spring repositories, like you can go ahead and use whatever the knowledge you already have with using Spring Data JPA repositories or Cassandra repositories with Yugabyte DB. Underneath, using Yugabyte driver, which is compatible with these projects, you get the cluster awareness as well as the partition awareness, which means the things like Amey mentioned, right? Like using a load balancer, all those things will go away. You don't have to maintain those things. As and when the cluster goes up or scales down, the app or the Spring Boot app automatically and like gets a notification or the change in state. It automatically takes care of all those things. So as an app developer, you will just need to understand your use case, the domain, whatever knowledge you have, and go ahead and start implementing your queries. On top of that, Yugabyte supports all the things you might be familiar with, like using secondary indexes with your table. And also one important thing is Yugabyte, both YSQL and the YSQL APIs are distributed ACID compliant. Like the transaction are ACID compliant. So you don't have to worry about it. Like it works with Spring Data or Spring transactions like natively. You don't, as an app developer, there is nothing new that you would have to do.
Right.
In next few slides, Amey is going to just walk us through the sample application or the sample microservices we'll be building using our APIs. Go ahead, Amey.
Thanks, Nikhil. That was a great overview of Spring Framework. So folks, at this point, we just wanted to present to you what you'll be building in the workshop session today. That is, over the next period of like 75 to 80 minutes, we'll be focused on building two separate microservices. The first one on the right-hand side top that you see is something called as a product catalog microservice. And the simple reason here is that we took retail as a domain, which most of us are familiar with based on like online shopping and being customers of some of the top tier retail outlets that are available in the industry today. So for the retail, if you're trying to build your own online e-commerce store, these are the two specific microservices that you would have to implement no matter what, right? So the first on the top right hand side that you see is a simple product catalog service. or think of it as a product lookup service, which would serve you the right information at any given point in time. And the reason we chose this microservice for this workshop was because this is a one which demonstrates the high need of uptime and resiliency, and at no point in time should serve a stale data or a stale copy of data for that matter, right? So all of these qualities are already handled by Yugabyte database, and there is no special thing a developer would need to do to enable, like, or even like think through, like, how he should go about like designing this microservice. So for this specific microservice, since this is a product catalog lookup information, we are going to tap into Yugabyte's Cassandra compatible API, that is YCQL. And for this reason, we'll be using Spring Data Cassandra and querying this product catalog information through it. The sample data for all both the microservices are provided to you as part of the GitHub repository. The second microservice on the right hand side bottom that you're looking at is the cart microservice. That is, whenever you have a catalog and an online store, you're obviously going to buy those items. So you'll be adding them to shopping cart and then executing a transaction to buy them or placing an order. And that's exactly what a shopping cart microservice in conjunction with an order execution system would be doing, right? For this one specifically, we have designed this using SQL fundamentals. So it's going to be using Spring Data JPA repositories, and we'll be doing a transactional ordered checkout here. So as opposed to if you're familiar with NoSQL databases where transactions are not possible across the system, this is where we'll demonstrate the value of Yugabyte and Spring working together to perform such a transaction here, or a checkout, if you would like to call it. On the next slide, you'll quickly see the topology of how these things will be working in together. So once you deploy these two Spring Boot microservices, you can choose to deploy Yugabyte cluster on any form factor, as we mentioned before. That is, you can run it on your local laptop or your Kubernetes cluster, or run it on Amazon Cloud or your bare metal servers. It doesn't matter to us. We will be providing you the data set and giving you the instructions on how to set up the Yugabyte cluster. During the session today, you'll see how to build and deploy these two Spring Boot microservices, so that end to end, you'll have a working example of how to build data microservices using Yugabyte and Spring framework. So from this point onwards, I'll hand it over to Nikhil, and he'll be walking us through the hands-on session of building these two microservices.
Thank you, man. So for folks who want to like just follow along with what we do, or if you are interested in the actual code that we have here, please go ahead and copy this bit.ly link. If you click on this bit.ly link, you'll be navigated to this GitHub repo. And this is the repo we'll be using today for most of the hands-on session. As Amey said, right, there's like two microservices, and I'll explain you the project structure. Before that, I just wanted to spend like a couple of minutes on the implementation details of our Spring Boot app itself, right? So what we are going to do today is we are going to obviously implement that Spring Boot app, right? So these are the 5 steps, these are the steps we want to follow when implementing each of these microservices. So the first thing, we want to see what are the dependencies that we want to use with Yugabyte API. And also next thing is we will show you what all the tables that we will be using for respective microservices, and all the object modeling that we have to, or the object mapping that we have to do, right, in the Spring Boot app. And the next step is like creating a repository for each of those objects, so that we are able to use them in our services and on REST APIs, right? And also we'll see how the database connection actually works with your Spring Boot. You might have like some doubts whether whether my Spring Boot application will be able to understand Yugabyte or not, all those things, right? We'll see how that actually works. And ultimately, we're going to end this session by implementing few APIs so that we can kind of read and write data to our database, right, using APIs. So this is what we are going to do with both the microservices. And if you see the GitHub repo itself, so in the GitHub repo, we have like 2 projects here, like cart microservice starter and cart microservice. The cart microservice is actually the completed code. If you want to cheat, you can probably go there and see how the code actually looks like. But for now, we will start with the starter projects. For both the microservices, we have starter projects like cart microservice starter and the product catalog microservice starter. So we're gonna first begin with the product catalog microservice starter. So if you go ahead navigate to this particular project, right, you'll see that we have few readmes here. Like consider this as labs. So we have like 6 labs where each step we are going to explain what needs to be done in each step. So the first thing, let's go and see what needs to be done on the YCQL, right? So if you see in the YCQL, like obviously we have provided a starter. However, if you want to like, let's say, go ahead and directly start using the Spring initializer. So for the product microservice, which is a CQL based, which is a Cassandra compliant, right? You would want to have a Spring Data Cassandra project as part of the dependency. That's the only dependency you will need from the Spring Data perspective for working with Yugabyte DB. So we have few other dependencies like Spring Data, Spring Web, and also we have Swagger because we want to have like a pretty UI, right? That's why we have Swagger as well here. What I have done is, let me go to my, so these are the 2 screens that I will be like kind of switching between. So one is my Git repo and the second is my like command line where I will be doing, where I have went ahead and cloned this project. So I have cloned this project. If you see, I have these brought down to my system. And next thing is I would want to like import this project into any IDE. Like if you are not interested in using IDE, if you want to use Vim, you can go ahead and do that. For now, I'm going to use my STS. So I have Spring Tool Suite where the first thing I'm going to do is I'm going to import one of these starter projects. Let me do that. It's a Maven project, so I'm going to use existing Maven project. I'll just browse where my project is. I'm going to go ahead and import the starter project. Okay, let me go to the starter project here. And let it build. Okay, I think the build is complete. Okay, now let's go ahead and take a look at the dependencies that we have added here, right? So this is important. The step that I'm talking about now. As I said, Spring Data Cassandra is the only project we need, but Yugabyte DB uses a different driver compared to a DataStax Cassandra driver. We have to exclude the DataStax Cassandra driver and bring in the Yugabyte Cassandra driver. The reason is Yugabyte, as Amey mentioned, we support distributed transaction with NoSQL API, as well as we have JSON B support. And there's like few other things like cluster awareness and partition awareness that are built into our driver, which is different from how a Cassandra would work, right? So that's why for a Spring Boot application, this is the only change you would have to make in your dependency when working with CQL. Okay. Now let's go ahead, and that's what we are going to be doing in the first step in the product catalog microservice. And before I actually go into the domain model in our second step, I just want to show you the schema for the product catalog microservice, right? We are going to be using 2 tables. One is the products table and another one is the products ranking table. So in products table, as I said, just the metadata, and the products ranking, we want to, we are going to use product ranking is for things like finding out top 10 products in a category. Like if you want to serve that kind of data, that's why we have created a separate table for product ranking. I'll not go into depth of how the domain modeling actually works in this session. It's out of scope for this. I'll touch upon why we actually went ahead and created these 2 tables for this use case. Most of the things will revolve around how we will be using these tables in our application to read and write data to it. And also another thing is we are creating an index on product ranking so that we can query on non-primary keys. So that, like category and sales rank. And if you see here, this is not a part of our partition key or clustering key, but still we can query based on the sales rank because we are creating a secondary index. That's one of the features that is natively works with Yugabyte DB. Okay. If you have any questions on the data modeling or what we are talking about, there's a live chat going on. You can go ahead and ask the question. We'll be able to answer it after this session. Like there'll be a live Q&A. Cool. Let me go to the second step for the product microservice and the product catalog microservice. If you see, the second step is creating the domain models for the tables that are going to be used in these microservices. So if you follow these labs or these steps, right, it just walks through like the step-by-step way of creating like step-by-step creating these domain models and how you have to go about it. So the first step, what I want to do is I want to create a product metadata domain. For that, I'll go to my start a project. I'll just go ahead and create the new package I need for it. I think the package is called domain. I'm gonna just call it as domain and create a new class here called product metadata, and I'm going to just copy these contents here. Like this is fairly straightforward. I'm going to just explain you what this actually means. So Yugabyte, if you're familiar with Cassandra or Spring Data Cassandra, all the annotations that you use with Spring Data Cassandra will continue to work with Yugabyte as well. So let me go ahead and get the dependencies. Driver. Okay, cool. So if you see some of the annotations that we are using the at table annotation. This is like mapping this domain object to the products table that we are using, right? And also, if you see, the primary key is asyn, and this is not a composite primary key; it's a single primary key. That's why the clustering key and will be the same. So and other things like column, a Cassandra type, and letting know Spring Data Cassandra what type of column it is and things like that. So this is pretty standard. Like as an app developer, if you are familiar with Cassandra, Spring Data Cassandra already, there won't be any change how you work with Spring. Okay, now we are done with creating the domain model for products table. Next step would be to creating tables for product ranking key and the product ranking. So if you saw the let me do one thing. I will open the image, I mean this table schema, so that we can keep a look at what's happening. So if you see the schema for product ranking is a composite key, right? It's basically asyn and category. The way we have to implement that in Spring Data is we have to create a composite key, so that we have to create a separate object for composite key and use that in the actual domain model, right? So that's why we had to create a product ranking key for a product ranking table and use it in product ranking.java. Let me go ahead and create a new class and call it product ranking key. Let me get the contents of product ranking key here. You get the contents of product ranking key. And if you quickly see the like the annotations that we are using primary key column instead of primary key, since this is a composite key that we are using. Okay, let me go ahead now, create the new class called product ranking. Okay, product ranking. Let me get the contents of product ranking. This is kind of boilerplate code, right? This won't change for change for any other use case you will be having or any other table that you would want to use with CQL. So what all we are doing is basically based. It's like a POJO that we are creating and like annotating this POJO with few things so that Spring Data understands like what is the table it is working against and also what are the columns it has to map to, right? So that this kind of works magically when we create repositories and access data. So it's pretty straightforward. I'm using the product ranking key I created in the previous step because it's the composite key. And a few other mappings are the mappings that I won't have to do with the domain model and my table mapping, right? I've just created all those things here. Uh, since we are short on time, I didn't want to like do it everything like on the go. That's why I just we have it as part of the completed project. I just copied it from there. Okay, now we have the domain object ready. The next step for us after creating the domain object, let me go ahead to the step number 3, where we have to create our Cassandra repositories. Okay, if you see the if you know the repository concept for each domain object you create, you have to create a repository, right? Repository is pretty much like an interface that you create, and Spring actually provides the implementation, or Spring Data provides implementation for it. Spring Data obviously provides like all the default methods for inserting, deleting, and updating. But if you have any custom queries or any other queries that you want to do, you can go ahead and create your own implementations using repositories, right? That's what we are doing here. We are creating a repository for product metadata, and in my get products, I am creating a custom query here so that I retrieve the products based on like the limit and the offset I want to create. This is like this AP, this query is going to serve my API for serving like say metadata product listing, like my homepage where I want to list a bunch of products, right? So if you want to do such kind of API, you would want to have limit and offset, things like that. That's why we have modeled this query against that kind of an API. Let me now go ahead and create a new package called repo. I'll come here and I'll say create new package. I'll call the package as repo. In this repo, I have to create product metadata repo. Let me create a new interface, call it product metadata repo. I'm going to just get this, get the contents here. I'm going to explain what each of those annotations means. Let's quickly see what's happening here, right? Let me bring down all the dependencies I need. Java util list. Okay, cool, we have here. So if you notice one thing here, we are creating a interface and extending the interface to use Cassandra repository. So all the default implementation that is provided by Spring Data Cassandra, right, which will work with Yugabyte as well. And also, if you know, if you want to override any of the if you want to override any of the default behaviors or create custom queries, you will have to use a query annotation, right? That will also continue to work with Yugabyte DB. There won't be any change to it. Okay, in this repository, all I did is I want to access the product metadata information, which is going to be a Cassandra repository. And now we have a repository access pattern for Yugabyte, right? So, and one other important or interesting annotation here is the repository rest annotation, which actually means that I want to expose my whatever the CRUD APIs that this repository provides as a REST endpoint. We will see when we go ahead and start this application how that will actually look like. For now, let's get to the next step. Let's go ahead and create a repo for product ranking. Let me create a new interface, call it product ranking repository. Product ranking repository. And similarly, this also extends Cassandra repository, and there won't be any like difference to what you are already be doing with Cassandra, or if your familiarity with Cassandra will continue to work with Yugabyte as well. Okay, now we have both the repositories ready, and the next step for us is to go ahead and create some services, or actually the next step would be to uh, tell my Spring Boot application or configure our Spring Boot application to work against the Yugabyte DB cluster. Actually, now it's a good transition to see where where the Yugabyte DB is running. So for this particular workshop, for the demonstration purposes, we actually have provisioned Yugabyte DB cluster on a public cloud. This is a 3-node Yugabyte DB cluster that we have provisioned, and if you see, it has three nodes where the actual data is going to go reside, and each of them hosts like few of the components. I'm not going to go into the depth of what master and T servers are. Just for the developer purpose, T server is the one responsible for storing the data. If you don't want to like understand the internal workings, it's just that you can stay with the APIs that is supported by Yugabyte DB. And also you can see all the tables that we have created as part of this workshop. And the few other things that you can see as an application developer, like if this was a live cluster, you would have seen like the operations that are like some of the metrics like operations, what is the like CPU usage on the cluster, things like that. It's like a one-stop place to finding out what's happening in your cluster. So this is the Yugabyte DB we will be working against. We already provisioned this, and we have loaded some data to it, and we'll be working against this cluster. Like our applications will be connecting to this cluster. Cool. Now let's get to the next step of configuring the YSQL data source, right? So since Yugabyte works with Spring Data Cassandra natively, like you don't have to manually go ahead and create any data sources per se. You just have to go ahead and configure some of the properties that Spring Data Cassandra provides. Like you just have to configure in application.properties, right? That's how Spring Boot configuration usually works. So let's go and go to our application properties and get these few properties that we want to configure. There's the Chronos is the key space that we'll be connecting to, and instead of the local host, we want to connect to the cluster that we have created, right? And I have it somewhere. Okay, let me go ahead and use one of these external APIs that we have here. And this is where that's how you just configure where the Yugabyte DB cluster is running. I mean, for HA purposes, you can provide the comma separated values. Like if any of the one is available, it will just connect to it. So that's all you need to do for configuring the Spring Boot cluster to connect to Yugabyte DB. There is like no other changes, right? And similar to that, I will have to create one more. I'll have to create the configuration so that I tell repository to go ahead and use this data source, right? I have to just configure that. So that's actually our next step here, like where I have to configure my Spring Boot application to enable Cassandra repository. Let me go ahead and create a class called Yugabyte YSQL config, and I'm going to annotate it with few things here, as you have seen. So these are like standard standard annotations, right? Like all I'm saying is enable Cassandra repositories and where all those repositories are. And this is the repository where we created our product metadata repo and product ranking repo, right? This just tells Spring Boot that it just has to scan that package to go ahead and provide an implementation for those repos. This pretty much this is all we need for connecting to Yugabyte. This is all the boilerplate code that you'll have to do. The next step, what we are doing is we are just going to create few services so that we can use this and expose it as an API. So let's get to the step 5, like where we want to implement the product catalog REST API so that we can expose few endpoints, right? Okay. Let's see. So we have to create a new package called service. Let me go ahead and create a new package here. I'll call it as service. And let me create a new class. Okay, this is the interface that we are creating, and create the IMPL later. Okay, cool. Let me create the product ranking service. Create a new interface, call it product ranking service. And let me get the content for this interface. So this product ranking service is going to use the repository, the repos that we created in the previous step, right? So Java util, Java this. Okay, perfect. This is done. Let me get the service class. Let us create a service class for product service. Let me copy that. Call it product service. Let me bring down the dependencies here. Okay, let's go ahead and create the IMPO for these classes. Let's call it service IMPO. Create a new package. It's called product ranking service IMPO. Let's create a new class here. Product ranking service IMPO. Let me go ahead and get the implementation details for it. Cool. Util. Perfect. So if you see one interesting thing that we are doing here, we are kind of auto wiring the repository that we created in the previous step. Like doesn't matter what use case or any other like any if you implementing this in your for your specific use case, these are the like common steps you'll be creating, right? Like in a standard Spring Boot application. So after you create the repo, the next step will be like using that repo in a service implementation. In our service implementation, I mean, we are not doing much. We are just finding the product by ID and also product by category. However, if you had like a lot of business logic that you would have to write for your use case, you would be pretty much writing that in your service, right? So in this, you can just see how simple it would be for you to port over to Yugabyte and maybe like use the existing application also. Like if it doesn't require, it won't require much change. Let me go ahead and get the next product service. It's called product service IMPO. Let's go ahead and create the service implementation for product service. I create a new class called product service IMPO. Let me bring down the implementation for it. If you see, even this is doing the same thing. I'm just auto wiring the product metadata repo that we created in the previous step. And we are using this in two APIs like find by ID and for find all products, which is like I want to page in it, right? If I have like a million or 10 million or whatever number of products, I don't want to like query the database for all those. Obviously, you need to have a limit, and you can set the offset and things like that. So since we implemented our service, let us go ahead and create few controllers so that we can expose this API as a REST endpoint. Let me create a new package called controller here. Let me create a new class called product catalog controller. This product catalog controller will have a bunch of request mapping so that we can expose some of the APIs for doing reading and writing into the product metadata. This product catalog is basically just for displaying data. So you will be only doing get operations on this. Okay, let's bring down the dependencies. I think all the dependencies are set. So if you see in the final step, all we did is we created a service in the previous step, and we are using that service in the request mapping. Generally, this is the best practice, right? Like you never bring in the repository into a controller class. You only use like a service in a controller class, right? So that's why we kind of followed the best practices of implementing a Spring Boot application. So this is very straightforward, right? Like all we are doing is finding the ID, like find by ID, which is like finding a product based on its ID, and finding list of projects, and finding top products in a category. We'll show you how some of these results would look like. Cool. That's it. I think the implementation of the application is all done. Let's go to the next step, running this app. So what I'm doing is I will go ahead and run this application on my workstation. So like currently I'm using Mac, and I mean, doesn't matter like if you're using Mac or Linux. So if you have Java installed, that's only the prerequisite we need. And we have provided Maven wrapper, so you don't uh, need to worry about installing Maven. So let me navigate to the product catalog starter service, where we go, where we kind of implemented all our code. So if you go back to the steps for running, uh, we have set up the tables already. The data load is already done. You just have to start the Spring Boot application. Let me go ahead and say Maven W Spring Boot run. Spring Boot run. This goes ahead and starts my Spring Boot application. Okay, let's give it a minute for it to come up. In the meanwhile, right, like if you are interested in Kubernetes based deployment, there are like actually steps for how you can Dockerize these Spring microservices, and how you can go ahead and implement in or deploy it on Kubernetes. Only thing is a few changes. I mean, in the config map, right? Like the application properties we kind of used here, we will be actually we'll be configuring that as a config map in Kubernetes. That's the only thing that you would have to do extra when you're deploying on Kubernetes compared to like bare metal installation. So quick thing, if you see here, I just provided a single node. Driver is capable to identify or is capable to discover all the nodes in the cluster. That's why I have, since we have a 3-node cluster, all the nodes are now connected. And we have this app running on 8082. Let me navigate to 8082 so that we can see some, we can go ahead and query data from Swagger. So if you're able to follow along till now, and if you're able to start the Spring Boot application, like if you navigate to localhost 8082 Swagger, actually it is provided in the run documentation here. If you see here, localhost 8082 Swagger UI index, this is where you have to navigate to open Swagger. And there's like few things happening here, right? Obviously, like if you remember, we mentioned we are creating a REST-based repository. That's why for each of my entity that I have in my Spring Boot application, I have REST access to it. So if you see here, I can use any of these API to get data from the table. And also this product catalog controller is the controller that we created. So I can go ahead and now query few things, right? Like let me go ahead and try this API out where we want to get like list of products, right? I go ahead and execute it, and you'll see some data coming in. So this is just some sample data that we have loaded for the products information. There's like around 100,000 products that we have loaded in the database. Now let me go ahead and do a point fetch for this. I'll try it out. I provide the product ID, and you'll see that data is coming out, right? So this is just to show how easy is it for you as an app developer who are familiar with Spring Boot. You can pretty much get started with Yugabyte and Spring Boot within like 15-20 minutes. You can complete the entire boilerplate code. And also, if you don't want to install Yugabyte DB on your in your workstation, you can use the free tier of Yugabyte Cloud. It will be like a easier way for you to get started with Yugabyte DB. Now let's go to the last API that we created based on the category, right? So I think we have a books category. I'll say books. I'll say limit 0, offset 0. This actually going to just give me like top 5 books based on ranking, right? To see the sales rank that I got, these are the currently in my the data in our database that we load the data. These are the top 5 books that we have. That's it, folks. That's all you have to know as an app developer to work with Yugabyte's SQL. So what we did till now is we went ahead and implemented the get product info, this part of the product catalog microservice. So any questions if you have for the product catalog microservice or the Spring Boot support for YSQL, please go ahead and ask those questions on the comment. There will be a live Q&A after. We can answer some of your questions there. The next step in our process, we want to implement the cart microservice. As Amey kind of talked about before, like cart microservice basically is going to use the SQL API, which is a relational API that is supported by Yugabyte DB. And we're going to see how we can implement the cart APIs, like adding items to the cart, deleting an item from the cart, things like that, using YSQL and Spring Data JPA. So these are the Spring projects we are going to be using for the cart microservice. We are going to use Spring Boot, Spring Web, and Spring Data JPA. Obviously, we also have Swagger dependencies on it. It's just to prettify the REST APIs. Like if you don't want to expose it, expose Swagger, or you have a different way of cataloging your APIs, you don't have to use Swagger. The main dependency that we'll be using for the cart microservice is the Spring Data JPA. Cool. Let's navigate to the cart microservice. Here, this is not the one that I wanted. I want the cart microservice starter. Cool. Similar to the product microservice, we have the similar steps here, 6 steps. We're going to see what dependencies we need as part of our Spring Boot project, the domain setup, how we create the repositories, how the connectivity setup would look like, and we'll implement few controllers to exposing the REST APIs, and we're going to run this application. Okay, let me go to the first step of initializing the Spring Boot application. So as I said before, we can go ahead and use the starter project, or we can go ahead and use like Spring Initializer. If you go to the Spring Initializer, these are the dependencies you will need: Spring Data JPA, Spring Web, Postgres driver, and JPA validator. If you believe validating your domain model is in line with your table definition, you would want to use Spring validator. The JPA validator. Let me go to my IDE. Let me close all these other files that we have. Let's go ahead and import one of the cart starter project. If you've already cloned this repository, you would see that already available on your file system. I'll see cart microservice starter. I'll say open. I'll say import. Similar to product microservice, the first thing that you want to see is look at the dependencies that we need for Yugabyte. So there's an interesting dependency here. Like Yugabyte is fully compatible with the Postgres JDBC driver. But Yugabyte actually extended the Postgres JDBC driver to provide their, our own driver, which actually supports cluster awareness, which means since Yugabyte is a multi-node cluster, right? JDBC only understands connecting to a single node, right? So that's the reason we had to extend this so that we can bring in cluster awareness to the driver. Otherwise, you would have to use the load balancer that generally people use. Using a load balancer obviously brings in an additional step, right? That's why instead of using the Postgres driver, we'll be using the Yugabyte's JDBC driver. That's the only change you would have to do with existing Spring Data JPA application. It's working against Postgres to make it work with Yugabyte DB. So if you take a look, this is the only dependency change that you have to do in your Spring Boot app. Cool. Let me go to the next step, creating the domain models. Before I get to the domain model, let's take a look at the table schema for this. Like if you see the shopping cart schema, right, it's pretty straightforward. If you have any other complex relationship like parent-child relationship you might have in your schema. So, and how you design that with your existing Spring Data JPA application will continue to work with Yugabyte. There are examples out there in Yugabyte repository, like where you can see how the Spring Data ORM works with Yugabyte. There won't be any change for you to be working with Yugabyte DB. Like existing knowledge you have with working with JPA will continue to work with Yugabyte as well. Okay, let me go to the domain model. So all we are doing is we are creating a domain model for shopping cart, like entity, right? We're going to create a entity for the shopping cart table schema that we just saw. Let's go ahead and create a new package here. I'll create a new package domain, and inside that I create a new class and call it shopping cart class. In my shopping cart, I'll just copy. I'll just get this Pojo that we have created. Let me create this. So if you quickly take a look, the entity and the table and all these annotations that we have here, right? These annotations, I mean, like you are already familiar with these annotations when using Spring Data JPA. So the same annotations that gets used with JPA and any other database will continue to work with Yugabyte as well. That's the only domain object we have to create for the cart microservice. Let me go ahead and create, let's now go ahead and create the repositories here. I will create a new package called repositories. I think I spelled it right. Now I'll go ahead and create a new interface here. New interface called shopping cart repository, and I will extend it to create. So you can either use CRUD repository or JPA repository. Right now, I'm using for this demo purpose, we are using CRUD repository. I'm going to make this CRUD repository to use the domain object we created before. And if you see the cart object, the primary key is string. Just might configure the repository to work with the domain objects. So if you see here, I'm not creating any custom implementations. Like CRUD repository kind of provides all the APIs that I need for this. Like we are just doing like add, update, and delete. So Spring by default provides implementations for all those. As an app developer, this is like the advantage of using Spring Boot, right? I don't have to write a bunch of boilerplate code. And if you're familiar with all these concepts, it's like there is not a lot of learning curve for you with Yugabyte DB as well. Okay, we created the repository, and now let me add a few of these additional queries that I want for the additional we want for the APIs. So there's few interesting things happening here. I'll come to it once I resolve these transactional. I will use Spring transaction. So there's few annotations that we have here. If you see here, by default, JPA repositories are transactional, CRUD repositories are not. That's why you can go ahead and annotate whichever query that you want to run in a transaction, use a transactional annotation. So Yugabyte will continue to work with the Spring Transaction Manager. All my updates, we want to all the updates that we want to support in this microservice, we are making it transactional, and the ones which are not needed, we don't want it to run in transaction. So just to say, just to make the point clear, Yugabyte will work with Spring Data or Spring Data Transaction or Spring Framework Transaction Support, Transaction Manager. So we created the repositories that are needed, and then we will expose these repositories as REST repository, right? Similar to the our other microservice we created, we are saying we want to expose this repository as a REST endpoint. Like all these methods that you see here, these will be exposed as an REST API. Okay, now we are done with our step of creating the repositories. The next step is directly going to how connectivity, how the Spring Boot application connects to Yugabyte DB, right? So as I said before, like there won't be any change that you would have to do if you continue to use the Postgres driver. Since we are using the Yugabyte DB's cluster aware driver, there is a new data source that you'll have to create. First, let me go ahead and copy the, let's configure the Spring Boot application so that we are configuring the JPA that is needed for this, JPA properties that are needed for our Spring Boot application. If you see here, I'm saying Yugabyte SQL data source URL. This is like the JDBC connection string for Yugabyte. Instead of localhost, we are going to use one of these APIs, right? Sorry, one of these IP addresses. So you will see, like similar to the product catalog microservice, just by configuring one of these, one of the nodes of Yugabyte DB cluster, this driver has the capabilities of discovering all the other nodes in the cluster. Cool. So rest of the properties are pretty straightforward, right? Like all we are saying is we want this Spring Boot application to work against Postgres SQL based dialect. That's why we are, since Yugabyte is a Postgres compliant database, we want to use Postgres dialect. We are configuring our JPA to use that. And as few other things like we want to generate the DDL and create the auto create the DDL, right? So for you don't have to use the DDL auto to create if you're in production, because you don't want to have multiple Spring Boot application dropping and creating your tables. You kind of let your schema migration tool or some other scripts to do it. For since it's a demo purpose, you can use the Spring or JPA's auto DDL creation for creating the tables as well. These configurations that we are doing is not it's not different for any other configuration you would be doing with Spring Data JPA, right? So those changes will continue to work with Yugabyte as well. And is there any, let me see if there is anything else that is important for us to talk here. Okay, cool, that's it. So this is the only important change that we have. Like instead of configuring Spring data source, we want to configure the Yugabyte SQL data source URL in the property so that we are able to use the cluster aware driver. Let's now go ahead and create a config file so that we use the Yugabyte DB's Yugabyte DB cluster aware data source. Let me go ahead and create a new package and call this package as config. We're going to create a new class here. We're going to call it Yugabyte data source config. And let me get the implementation of our configuration. Cool. So there's one important thing happening in this implementation. If you notice here, instead of using Postgres data source, we are using YB cluster aware data source. So this actually makes the Spring Boot application cluster aware, which means you don't have to provide a load balancer. And as and when there is a cluster change, which means if you have added new nodes or remove nodes, or for some reason there is infrastructure outage, node goes down. So driver able to like identify all the changes that are happening in the cluster. Otherwise, like client would have been like a very dumb client, right? Now client is kind of becomes intelligent using Yugabyte JDBC data source. Now we configured our Spring Boot application to use the Yugabyte cluster aware data source. The next step is implementing few REST APIs. Similar to our other microservice, we're going to use create a service and use that service in a controller class. Let's go ahead and create a service implementation for this. We're going to create a new package called service, and we call the service as, let me copy this over and create a new class called shopping cart IMPO. Get the shopping cart. Let's implement the shopping cart IMPO. So if you see here in my service, all I'm doing is I am first auto wiring the repository that we created in the previous class. So we are going to use the repository APIs for repository APIs in this service. And similarly, we're going to add the implementations for adding and deleting the card service using our repository classes that we created in the previous step. So let me go ahead and add the implementation for adding and creating the products. This is very straightforward implementation. There's not a lot happening here. Let us import shopping cart and import map object. Let me get all the dependencies first. Java list, Java map. Okay. So the first step, we got the repositories and we auto-wire the repository. Now we are using that repository in the service implementation, right? And if you see here, all we are doing is use the methods that we kind of created, right? There's like we are using some of the default methods as well as we are using some of the methods that we already or we custom created, or the custom queries we have defined in our repository. Okay, this is for adding the project, or like if there is a, like we have to identify situations like if there is a product already in the cart, you have to update it. There's like much more. This is not like a production based shopping cart application, right? If it was a production or if it's like a real world shopping cart application, you would see a bunch of business logic and a lot of algorithms that gets implemented in the shopping cart will be implemented as a business logic here. So as an app developer, you just have to see like how easy is it for you to like bootstrap this application to work with Yugabyte. So all the business logic you can just go ahead and use Yugabyte DB for your existing applications also. Okay, we are done with creating, implementing the adding and creating the products from the cart. And now the next step is for us to go ahead and create few controllers so that we can expose these as a REST endpoint. Let me create the controller. Sorry, first I think I had to create a new package. Let's create a new package called controller, and create a new class here called shopping cart controller. Okay, perfect. We have the shopping cart controller here. Let me get the implementation for our shopping cart. We'll go over what we are doing here. Okay, so we created we created a let's go one by one what we did so far. So we created a shopping cart domain. Then we created a repository for it. We created a service implementation so that whatever the business logic that we want to write, we can implement in service. And now we have created a controller where we are using the service that we created for exposing it as a REST API, right? Like using the REST API, your UI application can use this REST API for inserting and updating data to the cart. So this is pretty much how like you will go ahead and write a REST-based Spring Boot application. So we have few APIs that we are exposing here: add product to cart, get products in cart, remove products, and clear cart. So these are like very generic shopping cart related use cases or functionality, right? Adding to the cart, removing the cart. That's what we have implemented here. Cool. Now I think we have the implementation part done. We configured our app to connect to the Yugabyte DB cluster. Okay, and now let's go to the last step of ours, how to run this application. Okay, now let's go ahead and run this application on our workstations. So we have, you can go ahead and connect to Yugabyte DB and run, go ahead and implement or create the schema by yourself. Since we have configured our application or the JPA itself to go ahead and create the table, we can go ahead and just run this, run the Spring Boot app. It will create the table for us. Let me get to my CLI. Let's navigate to the cart microservice starter in our file system. So let me say Maven Spring Boot run. They should start our Spring Boot application. They're like once this application starts, right? In the logs, there's like few interesting things that we can see, like how the JDBC data source or the Yugabyte JDBC data source can go ahead and discover all the nodes in the cluster. If you see here, when the new connection initialization is happening, there are like new nodes that are connecting to the driver is able to connect. So even though we had like a single node that we have configured in our JDBC connection string, so this cluster aware driver is able to identify all the nodes in the cluster and connect to it. So this is like without having a load balancer, you have the capability of connecting to all the nodes in the cluster, right? And also, as I said, we had set the JPA to create, so it went ahead and created the table for us. Now, this application is running on 8080. Let's go ahead and navigate to the Swagger UI. Let's go ahead and navigate to the Swagger UI. Let me copy this. Swagger. It's running on 8080. Cool. Now, if you see here, similar to our product catalog microservice, we had annotated our shopping cart entity to be REST enabled. That's why all the default methods that repository provides is exposed as an API. And also, this is the shopping cart controller which we designed by ourselves, which is using all the distributed transaction that is support that is provided by Yugabyte DB. So let's try out few APIs. Let me go ahead and try the add product. I think we retrieved few objects here. Let me see. I'll use this ID. Uh, Let me use create a user ID. I think we have user 001. I create a ASIN and execute this. So this is just uh, this just gets added to our Yugabyte DB. So let me see if we are able to see the products in the cart. We'll try it out. Let's try the user. Okay. We have like a product that we added before that's in the cart. So this is like basically it's a simple implementation of our like a basic implementation of how you would handle a shopping cart, right? So ultimately, what we wanted to get out of this a demo or like this workshop itself is how easy is it for you as an app developer or like a Spring Boot developer to get started with Yugabyte. So there was like literally no new additions that you would have to do. Like the ramp up time that you need as a Spring Boot developer is very minimal, right? It's only like few dependencies that you would have to understand. Like what dependencies you have to use for YSQL API and what dependencies you have to use with YSQL. There's like only two driver changes you would have to do working to work against Yugabyte DB. That's how easy is it for you as an app developer to get started. So this is like a just sneak peek for you to understand like the deep integrations that Yugabyte provides with Spring Framework. That's all we had. It's like we created two microservices, product microservice and the cart microservice, which gave you a quick overview of how easy is it for you to get started as a Spring developer with Yugabyte, and to show like the deep integration that Yugabyte DB has with Spring Framework. Having said that, that's all I had for today's hands-on session. Just a closing note. Uh, we have a community Slack that you can join. We'll have Yugabyte DB R&D engineers as well as our field folks. Everyone are on that Slack channel. If you have any doubts on getting started with Yugabyte or Spring or any other questions you have, feel free to join our Slack channel. You'll get responses very quick. And also, like if you want to go ahead and install Yugabyte DB on your local workstation, you can do so. It's pretty straightforward to start it up on your Mac or Windows machine. And if you like Yugabyte DB, go ahead and start us on GitHub. Thank you, folks.